All right, guys. We've got a lot going on here in this lesson. I'm not going to go full screen because I want to be able to show you guys the things you need to be able to do and for me to be able to jump between some options. But your goal is to be able to graph a quadratic function and identify key features of the graph from an equation. And so what we start you out here with is the actual graph of a quadratic function. If you see here, we have y equals we have what's called a parabola. All right, that's the graph of a quadratic function is a parabola. And we know that it's quadratic because we have that x squared term. Now, if you don't have a graphing calculator, you're going to have to make an input-output table by hand. Everyone's going to have an input-output table, but if you have a graphing calculator, the calculator can do that for you. But what we're going to do is show you guys what that looks like to make an input-output table by hand. So if you take a look, this first grade point that we have here is at -2, so that means -2 is one of my inputs. If I input -2, I'm going to do -2 squared minus 2 times -2 minus 3. Now, this is something that you can do on a regular calculator. So if you have a scientific calculator, it'll do that for you. But we can do mental math. -2 squared is 4. -2 times -2 is 4, so this gives me 8. And then 8 minus 3 is going to give me 5. And if we take a look, that's exactly what the output is. If we take a look at the next one, we have -1 as our input, so you do -1 squared minus 1, or minus 2 times -1 minus 3. -1 squared is going to be 1. -2 times -1 is going to be 2, so 1 plus 2 is 3, and 3 minus 3 is 0. And if we take a look here, that's exactly what we have at -1. We're at 0. We would then plug in 0, and then we've got 1, 2, 3, and 4. And from here, guys, the plugging in should go a little bit faster. We're plugging 0 in for both of those x's. Now, the awesome thing about plugging in 0 is that everything cancels there in the front, and I'm just left with -3. And so there we have 0 and -3. From here, I'm going to have you guys name off the points from the ordered pair. So we've got 0, -4. I'm sorry, we have 1, -4. We have 2, -3. We have 3, 0. And then we have 4, 5. So you guys should notice some things here that happen. What happens here is that we end up with points that repeat. What we have here, ladies and gentlemen, is what we call symmetry. All right, so our quadratic function, this parabola, creates symmetry. All right. So what we're going to do now, guys, is go through quite a few definitions, and I'm going to be referring back to this graph. So here we go. When we talk about the a value of a quadratic function or of a quadratic equation, remember that's the coefficient on x squared. And every quadratic function is going to have an a value for it. If a is positive, then the parabola will open up. If the a value is negative, then the parabola will open down. And that should make sense, guys. If you think of positive as something going up towards the positive y values, negative is something going down towards the negative y values. Now remember, these symbols here stand for absolute value. So we're talking about the absolute value of a. If the absolute value is greater than 1, so if it's 2, a 3, a 1.5, then what we know is that this parabola is going to be narrow. But if the absolute value of a is less than 1, then it's going to be a wide parabola. And we'll get a chance to see that in action as we work through some of the problems. The c value, that's the constant of the function. So when we were in chapter 7 and we talked about A, B, and C, we're still going to use those same A, B, and C terms in the same position. Remember, ladies and gentlemen, if there is no C value, then it equals 0, okay? But the C value gives us the y-intercept of the function. So if I go back and take a look at the graph we had here, our A value was 1. It was positive. It opened up. My C value was a -3. And if we look here at our y-intercept, we cross the y-axis at -3. The zeros of a function. The zeros of a parabola, the first thing I want you guys to know is that sometimes you do have to estimate those. So sometimes they will be an estimate. But the zeros of a function are the x values with an output of 0. That's what we call them zeros. What you guys know them a little bit better as is these are the x-intercepts. So if we go back and look at the function that we had, I'll change colors here. We had 2 zeros. We had an output of 0 here, and we had an output of 0 here. We crossed the x-axis 2 places. We crossed the x-axis at -1, and we crossed the x-axis at 3. So what we would say here is that our zeros are x equals -1 and x equals 3. The axis of symmetry is the vertical line through the middle of the graph. And so if we go back and look at this parabola that we had here, we have a middle of the graph. We could fold this graph paper in half. We couldn't fold it on the y-axis, but we could fold it in half right here. We have this axis of symmetry. One of the things that we do know about the axis of symmetry is that it goes through the vertex. And I'm going to explain to you guys what the vertex is in just a minute, but that's a key component of it. Now, the axis of symmetry does have a special equation, guys, and we're going to learn that here, because the axis of symmetry isn't always as nice as this one is, where we can see it goes through here and hits here at x equals 1. So the axis of symmetry, because it's a vertical line, is going to be an equation. It's going to be x equals. Remember, our vertical lines were x equals because they go through the x-axis. Our horizontal lines were y equals because they go through the y-axis. But because it's a vertical line, it's going to be x equals. And the equation for that, the formula, is opposite of b over 2 times a. So keep in mind, ladies and gentlemen, I didn't say negative b. I said opposite of b. So that numerator is going to change signs based on the equation. If we look at our equation here, because we had a -2, our opposite of b would be +2. All right, let's keep going with some definitions here. Vertex. The vertex is the turning point of the graph. So ladies and gentlemen, if we go back and take a look at this parabola, It's going down, 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 and then it's just going up, 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 up. So this value right here, this point, ladies and gentlemen, is the vertex. If you take a look at your table of values, that one point that had no symmetry, that was your vertex. So you had identified the vertex all along, we just didn't have a name for it. That vertex is that turning point. Now there's some special things about the vertex that we want to know. The vertex is known as a maximum. So it's the highest point on the graph. If A is negative, so if it's opening down, then that means it's the highest point on the graph. It's a minimum when A is positive. So once again, if we keep going back to this graph here, our A value is positive, which means this vertex was the lowest point. There's nothing below that. Everything is bigger than that. If you look at your table, -4 is the smallest output. -3 is bigger than that. 0 is bigger than that. And 5 is larger than that. All right, 2 last terms here to wrap up here with parabolas and quadratic functions, and then we'll get into an example here. Domain is the set of input values. All right, for a quadratic function that we're going to take a look at, it's all real numbers. Those of you that had me first semester, remember that's the symbol I use for all real numbers. You can simply write all real numbers. And last but not least, we have range. Range is the set of output values. Now the range isn't as easily defined as the domain, because if we go back once again and take a look at this graph, there's no y values below that -4. There's nothing at -5, because I went down to -4 and started going back up. So I'm never going to have -5 as an output. I'm never going to have -6, -7, -8. So the range is defined by your vertex. And so what we're going to have you guys, what we're going to tell you for that, is that your range is going, if it opens up, if your parabola is opening up, we're going to have y being greater than or equal to the vertex. If it opens down, it's going to be y is less than or equal to the vertex. All right? So we're going to go through an example problem here, guys, and kind of flip back and forth between the screens here. We want to be able to graph this. I know on your notes it says on your own. We're going to do that together. And I'm going to show you guys how to use the calculator, how to identify these things. But before we get started, we're going to list out some of these values that we can. So we're going to fill out what the A value is. The A value is -1/2. The C value is -4. We don't know the zeros yet, so we're going to save that for later. But we can calculate the axis of symmetry. The axis of symmetry is x equals opposite of b over 2a. When we take a look at that, we're going to use the opposite of b. B was a +3, so the opposite of that is going to be -3. And then we're going to have 2 times a, and a was a -1/2. I'm going to simplify this denominator first, and so -3 is going to stay the same. I'm just going to do 2 times -1/2, which is a -1. As soon as I go through, and I finish this, I get x equals -3 divided by -1 is 3. Now what we know, ladies and gentlemen, is that that's the middle of our graph. So when we're talking about making an input and output table, this value has to go in the middle of our table. From there, I'm going to pick my other x values. I'm going to keep counting 4, 5, and then I'm going to count backwards 2 and 1. Now what we're going to do now, ladies and gentlemen, is we're going to let the calculator help us find these other answers. Now we could fill in domain, because remember domain is all real numbers. All right, so I'm going to switch over to the calculator, and we're going to do some work there. So you're going to turn your calculator on. We're going to go to y equals, let me do that again. You're going to turn your calculator on, and you're going to go to y equals. I'm going to have to remember to move this up and down. So we're going to hit y equals, and then you're going to check and see what you have. I have one function here. I'm going to clear it out. You may need to cursor down and make sure you don't have anything anywhere else. But I'm going to go to y1, and I'm going to type in -1/2. No, I'm going to do -1 divided by 2. I'm not going to do alpha y equals there and get a fraction, guys. You don't need it. -1/2 is good enough. We're then going to do x squared. I'm going to grab x from right here, and so that should bring an x onto my screen, and then I'm going to grab the squared, which is this 5th button here. So I have x squared. I'm then going to type in plus 3x, and then -4. Make sure you're using minus and not negative. Now what we already know, ladies and gentlemen, is we want our table to start at +1. We knew 3 was going to be in the middle, so there's a pretty cool feature on your calculator. It's called table set. And you can get your table to start wherever you want. So I'm going to do second table, and I tell it to start at +1. I want these to be all set on auto. But from there, I'm then going to do, I want to go see the table. So if you look above the word graph, there's the word table in blue. So you're going to hit second graph, and that's going to bring up a table. Now we have decimals there, and we shouldn't be surprised, ladies and gentlemen, because there was the fraction 1/2 in our equation. And so what we're going to do is we're going to copy these down. So on our table, and let's see if I can recall all of these, and it shouldn't be very hard, because all I have to do is I just have to remember 3 numbers, -1/2, 0, and 1/2. Because once I get to that vertex, and if there's 3, the numbers start repeating for that symmetry. Oh, that's not what I want to do. Sorry, guys. So I'm going to go to my table. And I'm going to have -1.5, 0, 0.5, 0, and -1.5. I'm going to double check my calculator and make sure that's what we had. -1/2, 0.5, 0, and -1.5. Beautiful. I'm then going to graph this. So I'm going to go to 1 and -1.5. So you're going to have to estimate that decimal. 2, 0, 3, 1/2. But then we have the repeat, 4, 0, and then 5 and -1.5. I'm going to try and connect those with as smooth of a curve as I can so I get that parabola shape, and I put my arrows at the end. I look at that, and my parabola is opening down, which it should because I had an A value of -1/2. Now I can check that, ladies and gentlemen, and make sure I am in the right spot by going back to my graphing calculator. If I go to my graphing calculator, and I hit graph, it's going to plot those points for me. And so this is just a way of double checking that, in fact, I didn't make a mistake. Now, if you type the equation in wrong, guys, there's nothing I can do for you there. So you do always want to make sure that you have that right y equals, that you have x squared, that you've got x where you need it. But we know what that graph looks like there. So what we want to do now, though, is we want to take a look at completing the rest of this information. Now remember, zeros, if we go back to that definition, zeros were the x values that had an output of 0. It was the x-intercept. So if we look at this, we had 2 x values that gave us outputs of 0. So for our problem, our zeros are going to be x equals 2 and x equals 4. Now we know what the vertex is that point that doesn't repeat where that axis of symmetry started. So our vertex is 3 and 0.5. And then the range, if we remember what the range said, the range is going to be based on the y value. If we take a look at this, my parabola opens down, so everything is below that. So my range is going to be less than or equal to. And remember we said we're going to use the vertex to help us. So if we take a look at what our vertex is here, our vertex is a y value of 0.5, so we're going to be less than 0.5, less than 1/2. Now, ladies and gentlemen, we're going to work on the next one in class tomorrow. We'll kick that off. But this is what I expect to come as completed for tomorrow. Have a good evening.